one seems very frightening, let's try to recap a little bit. Little bit. No problem. No more Kahoot. No time.
Alah, please.
We can do it later, yeah?
Later one.
So, you know fluid mechanics, right?
Yes.
This is study of fluid in motion and when it is
At rest.
at rest. Okay? The one at rest, we call it fluid static. You still remember the force of pressure, FP?
Yes.
Okay, when you calculate how much is FR and then at which location you work. You know, the problem is not the fluid mechanics, the problem is static. Because you need to calculate the moment of force. Okay? Most of the time, the problem is not with the concept of fluid mechanics, but your nightmare with the mathematics. I do not know why you guys so not familiar with mathematics. Okay, hopefully from now on, mathematics become your best partner. Because you like it or not, you are taking engineering. You are taking engineering pathway. Mathematics will always be there. You like it or not. Okay, so start to be good with math. Okay. You have a pile of water. When there is nothing there, it is fluid static. When you put the hose, it becomes fluid dynamic or static? Really, it becomes dynamic. Just putting a hose there.
Oh yeah. Static.
Nothing will happen, right? You put the hose there, nothing will happen. But if you siphon it, flow start to move, or you start to have the flow, then you have a fluid dynamics. Okay? Is it fluid static or dynamics?
Inside is dynamic.
Static or dynamics?
Static. Both apply. So it's static.
To be honest with you, it is relative. If you are looking at the dam itself, it is a fluid static. You can see there is overflow. So there is a tunnel inside, which make it a fluid dynamics. Right. So you need to design to define your system, whether it is static or dynamics. Okay. When you are dealing with fluid dynamics, you have fluid pneumatics and fluid dynamics. Anyway, don't care about that. Whenever the fluid is moving, you have a fluid dynamics. It's the simple one. If you have only considered velocity, acceleration, and flow pattern without talking about stresses, because you hate stress, but unfortunately we need stress. So if you have stress, then it becomes fluid dynamics. If you disregard the stress, it becomes fluid kinematics. As simple as that. Getting worse. Okay, this is all that we have. Fluid dynamic has the dynamics and kinematics, and the dynamics has hydrodynamics that we will look into when we are dealing with turbo machinery later. Gas dynamic that we will deal when we are dealing with the compressible flow later. Chapter 3, Chapter 4, Chapter 3, Chapter 1 and 2. You are so lucky, right? Fluid mechanics 1, you are dealing with that. Still remember Bernoulli equation? It's all about that. Now you move to that. So you can see the relation now. Why it is split into fluid mechanics 1 and 2. So this is the hydrodynamics. When you have overflow, it is like that. Or when you design a submarine. Okay. This is the gas dynamic. If you fly using aircraft, you know there is something big hanging on the wing. Yeah, that is the aircraft engine, and those engine is turbofan is working based on the gas dynamics. We are dealing with compressible flow that you have never learned it in your fluid mechanics 1, because in your fluid mechanics 1 we are dealing with incompressible. Usually you will deal with incompressible, steady state, inviscid, right? Now we are dealing with viscous, compressible, unsteady. Nice one. Okay? The good thing about it is you can design a Porsche, you can design a Shinkansen, you can design A380. The beauty of fluid mechanics. Without fluid mechanics, you cannot fly. Okay? The one that we learn later on, the Prandtl boundary layer is the basic of a monoplane. Okay? That is the basic of monoplane design. Who hate mathematics? One, only two? Who hates mathematics?
I love mathematics.
Who do not like mathematics? Okay, so most of you are good with mathematics?
It's like
Only two I need to pay more attention. The rest will be okay, right? You know that, right? You know this? Whenever you derive equation, you start with a very small cube. Why we choose cube? Because Cartesian is the best or the simplest coordinate that we use usually. Right? We do not use a spherical or cylindrical coordinate. We develop using this Cartesian. Okay? So if you want to know, if you want to analyze a fluid flow, you need to get the mathematical formulation of it. You have a car. Okay, bear with me, I'm not a good drawer. You have a car. Velocity 0 is 30 kilometers per hour, right? Then the driver push the accelerator. A is 30 meter per second squared. You push it for 10 seconds. Okay? After 10 seconds, what will be the distance from here to there? Still remember?
yes.
Will be T. This is the equation that governs the movement of the car. Right? Have you ever imagined you are in front of a desk fan? You know the desk fan?
Yeah.
You got the air coming to you, right? Can you express those movements in this equation?
Convert to
What do you need?
radius.
Same as your car. You are so smart, you can predict those Porsche. Okay, those maps. From there to there, it will be this, right? Now, we have a desk fan moving slowly. How can you describe the flow? If you treat the flow as inviscid, steady, incompressible, you can estimate it using Bernoulli equation, right? Now, what if that is not incompressible, which means it is compressible? It is unsteady because the blade is not steady, right? Sometimes you got the blade, sometimes you do not have the blade, then the next blade, which means it is unsteady. How you find the fluid. This, that, right? If you are talking about the flow only, right? But it is not as simple as that. You turn on the fan because you feel hot. When you turn on the fan, you feel cool, which means there will be heat transfer occurs. Right? And this equation of state is when you are dealing with the thermodynamics, especially when you are dealing with compressible fluid. And dimensional homogeneity. Who still remember what is dimensional homogeneity?
Apple plus apple.
Apple plus apple equal to two apples. Apple plus oranges become
Oranges.
become
Become lah. Not homogeneous.
become a mixed juice, right? Okay, so all of these are just recap from your fluid mechanics 1. So solid, you know the difference between solid and fluid. You know, if you are talking about stone and water, you can differentiate it easily. This is fluid, this is solid, right? But some material like polymer is neither solid nor liquid. Sometimes it behaves like a solid, sometimes it behaves as liquid. So how do you differentiate it? It's basically based on the deformation. If you are dealing with solid, okay, when you apply the shear force, it will deform a little bit. Then when you release this, it will return back. It has a finite deformation. But if you pour water there and you apply shear force, what will happen? It will keep moving as long as you keep the shear stress on it. So that is the basic difference. Okay? Fluid, it undergoes continuous deformation. Solid, it undergoes finite deformation. Okay? So the difference between gases and liquid is that I think you can read it through. Anyone do not know what's the difference between gas and liquid? Gas fill up the container, liquid settle at the bottom part. So how do you characterize a fluid? You know that it is in your fluid mechanics 1. You characterize it based on the heaviness, fluidity, compressibility, phase change, and cohesiveness. Heaviness, you know that mercury and water is totally different, right? Have you compared? Mercury will be 3 times or 8 times heavier, right? And then when we are talking about oil, you have a cooking oil, you touch it, what do you feel? Sticky. When you have water, you feel normal, right? Because we used to water. Maybe if we born and we usually take a bath with oil, you feel that oil is the best one. Because we use water, that's why we are too familiar with water. Right? So the difference between this oil and water is not about the density. The density may be roughly about the same, but it is the fluidity. Fluidity is viscosity. Right? You can compress the air, you cannot compress the water. You can actually, you can try to compress the water. But you will need a huge amount of force just to compress a little bit. It's not absolutely incompressible, it is compressible. But you need to have a huge amount of force. That's why practically it is considered as incompressible. Phase change, okay, sometimes you have vapor, sometimes you have liquid. And then cohesiveness, some fluid love to be in your skin. Okay, for our ladies here, usually you have a makeup with this waterproof, right? You do do not want that if you take wudu, your makeup gone. It's not true. You need to remove it. Okay, but my wife has it. My wife has a waterproof makeup there. It's quite expensive. But then whenever we go to R&R to pray, she need to, have a makeup removal to remove all. Then apply it back later on. So that one can be decided using that surface. When your liquid has a big, small, then it is a hydrophobic. Some liquid is having a big angle of contact. So when you put the water in a surface or liquid in a surface, it can form like this or it can form like that. Okay? When you have it in a small, it can have like that or it can have like that. This one goes to that, this one goes to that. You know the reason, right? This. Okay? Dimension, you cannot add apple and lemon or pear. Here. Yes. No lemon here. Okay, I think this is the last one. Two systems are commonly used. Sometimes, most of the time, we are dealing with international systems, right? Liter, second, kilometer, and so on. But unfortunately, BG system is still there. When we are dealing about oil and gas, you will not hear they sell, I want to buy crude oil 10,000 liter. No one sell oil using kiloliter. They sell it using a barrel, right? Barrel, one big barrel. Okay, and the production of oil is also in a barrel per day, billion barrel per day, BBOD or something, right? So, unfortunately, British is still being used. Even though in UK, they are not using it anymore. The one who are using British system now?
American.
Yes, American. American love British so much. So they use it. Okay, so that's about it. This is what we have learned.